Oh my goodness!
Oh my gosh!
Oh my goodness!
That's a gate, dude. That's a gate.
That is a gate. That's the gate.
That is one of the gates. This is my safe cracking robot, and I've been working on this project on and off for over 6 months. I've gone through quite the roller coaster to get to this point in the project, and I've documented all of the ups and downs in the first 3 parts of this series. There's been a huge development that could potentially derail this whole project. I have a moving truck coming to my house in about a week, and I have to have everything in this whole office as well as all of the tools in my garage packed up before they come. The safe needs to stay here in Arizona because it's my brother-in-law's. Now I'm on a tight deadline to finish this project. One way or another, I need to have this safe open in the next 5 days. I've been so frustrated with how little documentation there is on this specific safe. The brand is no longer around and they don't make this safe anymore, so there are no user manuals anywhere to be found on the internet. So I was incredibly happy when my friend and channel member Jonathan Ransom sent me a link to a lockpicking forum where somebody was able to open this exact same safe. They documented their whole process with a whole bunch of pictures of the internal mechanism of this safe, and they wrote out a procedure on how to crack it. So I'm going to try some of the techniques that I learned from that forum post. This is called a dial indicator, and it's a machinist tool that's used to measure very small dimensions. It can also be used to measure very small movement of things. It has a little spring-loaded pin here that moves back and forth, and then you can read out the measurement on the dial here. The forum post suggested that I put one of these on the handle, and that way I can measure how far the handle moves as I'm checking a combination. The reason I need to be able to measure the movement of the handle has to do with false gates. If you go back to part 1 of this video series, I talked about how the wheel on there will have 7 false gates and 1 true gate. So the false gates do not allow the deadbolt to slide all the way in. It's only that true gate that allows the deadbolt to unlock the safe. After reading the forum post, I learned that this particular model has false gates on all 3 wheels, not just that 3rd wheel. So hopefully I can use this information to really narrow down the number of combinations I have to try. If I try to turn the handle on a spot in the wheel that is not a gate, the handle doesn't turn very far. But as soon as I reach that gate, even if it's a false gate, the handle moves just a little bit more. That tiny additional movement is kind of hard to perceive with just our hand, but the dial indicator will do a great job of measuring that. The author of the forum post wrote out a whole bunch of step-by-step instructions on how to use this method to find all of the false gates on all 3 wheels. So that's what I'm going to try first. In the forum post, the person was just dialing by hand, but since I have a robot that will do that for me, of course I'm going to use that. So the first thing I need to do is figure out how to mount this dial indicator to the safe door so that it interfaces with that handle. And as the handle moves, that pin will push in. To mount the dial indicator to the safe door, I bought yet another giant magnet from Amazon. At this point, I think I've bought every giant magnet that Amazon has to offer. They call these things fishing magnets, and as far as I'm aware, I don't think you can catch fish with them, but I do know that if you tie a rope to them and throw them into a lake or river, you can pull out some pretty incredible things. So I'm going to use the threaded rod on here, and I 3D printed this little adapter that screws onto the threaded rod, and then the dial indicator will attach to that. I'm about to take my fingers off. So you can see as I turn the handle, the dial spins around and I can get a very precise measurement of how far it's traveled. I'm not looking for any absolute measurement here. I'm actually just looking for the difference between when the handle is tried on a non-gate position versus a gate position, because I'm looking for a little bit further travel when it hits a gate. So at this point, I literally just needed to push the button, let the auto dialer dial in the right position, and then I would take the measurement and record it in my notebook. I quickly got a sense of which measurements I could safely ignore and what the outliers were that I needed to record in my notebook. This meant I could cycle through a lot of the numbers pretty quickly because I could tell right away that they were not gates. At this point, I think I found all of the gates on all 3 wheels, and these numbers look pretty promising. So for that first wheel, I think my potential numbers are 8, 21, 34, 49, 59, 85, or 94. And for wheel 2, I think my potential numbers are 19, 35, 50, 77, 85, and 90. And then for wheel 3, those ones are much more obvious because I can feel them. The numbers are 12, 21, 34, 47, 59, 72, 84, and 97. Just based on my measurements, I think that wheel 1 is the number 8, and wheel 2 is the number 77, and wheel 3 is the number 47. So I'm gonna try that combination first. Okay, so I need to turn the dial right until I get to 8, then go past my second number until I arrive on 77 the second time, and then 47. Oh my gosh, my heart's pounding. Oh, dang it. You can tell it kind of gets caught because like one or more of those could be right and the handle falls in a little bit further and it kind of binds up. Which is probably what was happening in my longer auto dialing sessions. When I would get to 1 or even 2 gates that were correct, then that handle would get bound up and it would make it really hard for that servo to move it back. Even by hand I can tell that it's like that. I'm looking at my page of data here and that first number could also be 59. That was also a really strong candidate. So let me try that. So turn it all the way to the right and go to 59. Then 77, and then 47. Please. Oh man! This will be the last video you see me here in this office and in this shop here because I'm moving. I'm looking at my project list here on my computer and I've got a lot of cool things on the horizon. In the meantime, if you want to be more involved in the projects that I'm working on and learn more about it, a great way to do that is to become a channel member. I've got a Discord community that has helped me out a ton on this safe cracking project. They got to hear the behind the scenes play-by-play on how this project ended up coming together, and I'm really grateful for all of the suggestions and help I received from them. I love making these project videos and that's not going to end anytime soon. If you can appreciate all of the hard work I've put into this, please consider becoming a channel member. So I've tried everything to open up this safe and as you can see it's still locked up. So I've brought my brother-in-law Levi. He's come over. This is the end game strategy. I'm moving next week and the moving trucks are coming. I've got to pack all this stuff up. We've got to get this safe open. So I discussed some options with Levi and I sort of talked him down from using a destructive way of getting in. He wanted to use like an angle grinder to get in here, but I talked him into trying this first. This is a borescope. So this is a tiny little camera that is like the size of a pen. It's smaller than a pencil, but our plan is to drill a little hole in a specific spot on there so that we can stick this camera inside that hole. And the goal is to be able to see the wheels and so that we can align all of those wheels up visually using what we see on the camera as opposed to everything that we've tried so far. So that's what we're gonna do. I'm gonna take off the auto dialing robot and we're gonna start drilling into this thing. So at the end of this, the only thing we're gonna have on there is just a little hole and hopefully we can figure out a way to fix that, right?
Yes.
How do you feel about this plan?
I think this plan was better than my original plan, which was to just hack off the entire back end and then mount it to the wall afterwards. So it's a more elegant solution.
Well, don't speak too soon because that may, if this fails, that may be what we end up having to do. All right, let's get to it. So the only thing I'm worried about with this plan is how hard the metal is. So like better quality safes will have like hardened steel, and which makes it really hard to get into. Like it'll dull your drill bit faster than anything else. So I'm not sure what quality this is or if my drill bits are gonna even get through it. So if we start drilling and nothing's happening, we may have to come up with another plan.
But considering how much I paid for this, I think that'll work.
That's true, because it's a pretty entry level.
Yeah, it's a very entry level.
Okay,
safe,
so it's not like Fort Knox. It's not like
no,
titanium, really tough steel or anything like that. This comes off.
This was really a cool setup, though. Like legitimately, this was such a cool setup.
I wanted it to work so bad. So the 3 wheels kind of sit directly behind the dial here. And so I'm thinking that if we drill kind of in this area, we want to kind of get a top-down view of where the latch goes in. So I think that's the plan, is to kind of drill right here.
Okay, let's do it.
Okay. Any final words?
God bless.
God bless.
God bless and Godspeed.
Okay. Where do you think? Right there?
You tell me.
Yeah, I think I'm good. right there. Oh yeah, it's cutting right away. You can see the metal shavings.
Yeah, you know why?
Because it's cheap. Bingo. Okay. Oh my goodness!
What?
It's dark. I could push it against that back wall and maybe bend it down. There we go.
Oh my goodness!
Oh my gosh!
Oh my goodness!
That's a gate, dude. That's a gate.
That is a gate. That's the gate.
That is one of the gates.
Do you have masking tape or something so we can hold the line so it doesn't?
I've got putty.
Yeah, okay, where's the putty?
Hold on. Oh my gosh, dude. This is gonna work, dude! Do I risk moving this?
Like, look at all the false gates there. There's the other gate.
It's too close. I want to back up. I want to get a little wider shot. Oh, where is it now?
It's behind, so the gates are right here. Oh, there it is. There it is.
You see it?
There's the gate.
Wait, why is it on the other side? I don't get that.
This just because instead of going from the top, this is not bad. Is that
the metal bar?
Yeah!
Yes!
Yes! Sorry, this is...
Okay, give me the putty.
Okay, you got it.
This is exactly what we needed, dude.
I know.
Okay, can you turn me a piece
Yeah,
off?
I'm tearing it up. Here you go. I'm sorry. This is entirely too exciting.
No, I need this. I need the whole thing. I need the whole thing. Okay. Oh my gosh. Oh, we're gonna wake up my kids.
That's fine.
This. Okay. Dude. I'm just trying to stretch it so that when it relaxes, it's in the right spot. That is like really close. How do you like that?
It's like surgery. It's perfect. It's perfect.
Okay.
Oh my goodness!
Dude, we can see it. We can see it. Okay, so we're looking. Okay, so we're moving. We're gonna try to line this one up first, the far left one.
So go slow.
So that's a false gate. That's the real one right there.
That's the real one. What
That's
number is that?
90.
90.
So that's the first number.
Okay.
So like I said on the phone earlier, I'm doing right, left, right.
I totally have the number wrong.
Well, no. So my first and second number will be different than if you do left, right, left.
Okay, got it.
So that's that, and now we're gonna turn this one back. So we're gonna reach 90. As soon as we reach 90, it's gonna start spinning that second wheel.
Yeah, go slow so you don't touch the other stuff. This feels like the Italian job, man.
It's gonna grab the second wheel right now. Okay, you see that?
Yeah.
Okay, so false gate. We should write the, oh, there's the real one. There's the real one.
Okay, 90.
Can you write this down?
Yeah. Where's the?
There's a notebook right next to you,
Got it.
to the left of you.
90 and what?
90 and 6.
Okay.
Oh, I did that wrong. That's okay. Went the wrong way.
It's fine. We can get this one.
I can move this one without disturbing the others. Is that another false that just passed?
Yeah. That's it.
That's it? Yeah! We did it, dude. We did it. All right, so
Okay.
Levi, I think you should do the honors of opening it up since it's your safe.
Got
Cool
it.
with that? All right, show everyone what's inside.
Okay, you ready?
I'm sorry I had to rickroll you there, but I gave Levi the chance to empty out his safe because the internet doesn't need to know what's in his safe. That's his business. So if you were curious on what was in Levi's safe, it's going to remain a secret.
Holy cow, this is great. So, should we try it again?
So I'm gonna do left, or yeah, this is left 82. Right 11. And then left 47. So I've got the robot installed on the door, and I wanted to show you what this looks like from the inside, but I discovered something kind of shocking. I ran this through and it passed the right combination, meaning that my handle servo will not turn this far enough to trigger the limit switch. I increased the travel distance and I could not get this thing to actually trigger on the right combination, which is really frustrating because that means that during my long auto dialing session in the last video, I absolutely reached the right combination and I'm sure that the deadbolt slid in there, but it didn't go far enough to trigger the limit switch. So that's really frustrating. So let me show you what I'm talking about. Okay, so here's the right combination. That's the right combination, and it didn't trigger it. Do you see that? So that just shows me that I had the auto dialer working just right. It was the handle servo actuator that was the problem. And I also kind of blame the poor construction quality of this safe. The handle is extremely hard to open. There's a lot of friction and binding that goes on, and it's just sort of a cheap design. So my auto dialing session was sort of doomed from the beginning. But at this point, I'm done with this project. I need to move on. So I'm gonna fix that hole that I made to put the camera in. And what I think I'm gonna do is I've got some threaded rod here, so I'm just gonna tap some threads into this hole on both sides and then thread it in there and then tack weld it on both sides. At that point, I can just grind it flat and touch it up with a little bit of paint, and it should look pretty good after that. We are thrilled that we got this thing open. It turns out that all it took was an $18 camera and what, 15
minutes maybe.
15 minutes open. Oh my goodness. So yeah, I overcomplicated it.
No, but I think the journey, it's joy in the journey.
It was fun.
Yeah.
It's been really fun. I'm so happy that you gave me this project.
No, thank you, brother.
And yeah, if you ever have any problems like this again, don't call me.